Hey everyone, and welcome. Have you ever stopped to think about how all the amazing tech in your car, everything from the automatic braking to the fancy touchscreen, just works every single time? Well, today we're going deep into the hidden blueprint that makes all of that possible, and more importantly, keeps you safe.
I mean, just think about it for a second. A modern car is basically a supercomputer on wheels, right? It's packed with dozens of little computers called ECUs, or electronic control units, that manage absolutely everything. On top of that, you've got ADAS, the Advanced Driver Assistance Systems, making split-second safety decisions. So with literally millions of lines of code, how on earth do car makers stop one tiny bug from causing a total disaster on the highway? The stakes are unbelievably high.
So what's the secret? Well, the answer is a really disciplined and time-tested philosophy called the V model. And listen, this isn't just some boring flowchart. You should think of it as the auto industry's master plan for taming all that crazy complexity and building safety in from the very first step. It's their blueprint for getting it right. Okay, so what is it exactly? The V model is a framework where every single phase of development is perfectly mirrored by a testing phase. And that V shape, that's the whole point. The left side of the V is all about going down, breaking down the idea and designing it. The right side is about going up, testing and validating everything you built. That symmetry, that's its superpower. So let's take a trip down the left side of the V first. The best way to think about it is like designing a massive skyscraper. You don't just show up on day one and start laying bricks, right? No way. You start with the client's big vision, and you break it down step by step into super detailed plans before a single piece of steel is even ordered.
And this process of breaking things down, or decomposition, is absolutely crucial. It all starts with a simple customer need, something like, hey, the car needs to brake by itself if something is in the way. Okay, great. That gets translated into specific system requirements, things like sensor ranges and how fast it has to react. From there, engineers map out the system architecture, how the sensors, the processors, and the brakes are all going to communicate. And finally, you get to the nitty-gritty, the detailed software and hardware designs. These are the low-level blueprints for every single component.
And that brings us right to the bottom, the very tip of the V. This is the implementation phase. In our skyscraper analogy, this is where we break ground. The blueprints are done, now the actual code gets written, the circuit boards get printed, the vision is finally starting to become a real, physical thing. All right, now for the fun part. Let's start climbing up the right side of the V. This is where the real magic of this model happens. See, we don't wait until the entire skyscraper is finished to check if it's going to fall down. Of course not. We inspect the work at every single stage, making sure that every part perfectly matches the original blueprints.
Every step up the right side is directly testing a step from the left side. We begin with unit testing. That's like checking every single brick to make sure it's solid. Then you have integration testing, where we check if different parts work together, like making sure an entire floor of our skyscraper is sound. After that comes system testing, where we check if the car's entire braking system does what it's supposed to do. And finally, at the very top, you have acceptance testing. That's like the final walkthrough with the client to prove, yep, we built exactly what you asked for.
And here it is, the big aha moment, where it all clicks. Just look at how each design phase on the left has a direct partner on the right. The detailed software design is checked by unit testing. The overall system architecture is checked by integration testing. And this is the whole point. You don't design anything without already having a plan for how you're going to test it. It's brilliant.
Okay, so we get the process now. But why go through all this trouble? Why is this rigid structure so important? Well, it all comes down to one word: safety. This super discipline approach is the backbone of major automotive safety standards like ISO 26262, which is basically the international rulebook for making sure the electronics in your car don't fail in a dangerous way.
This whole structure gives us three huge benefits. First, there's traceability. You can literally draw a line from the initial customer idea all the way to the final test that proves it works. Second, early error detection. By thinking about testing from day one, you can spot a bad idea before you've spent a ton of time and money building it. And finally, it reduces risk. If something does go wrong, this detailed map makes it way easier to hunt down the problem, whether it's a tiny bug in the code or a massive flaw in the design. Now, I know what some of you might be thinking, especially if you're in the software world. What about Agile? In a world of fast updates, doesn't this super rigid model seem kind of old-fashioned? And that's a totally fair question. The answer really gets to the heart of what makes engineering for cars so unique. Look, the V model and Agile are just different tools for different jobs. Agile is amazing for your car's infotainment app, where you can develop quickly and push updates. But you can't exactly push an over-the-air update to your physical brake pads, can you? For those safety-critical systems, the V model's rigidity isn't a bug, it's a feature. It guarantees things are done right. In fact, most car makers today use a hybrid approach, using agile methods within the big, safety-first framework of the V model. So, let me leave you with this final thought. As cars keep evolving from just helping us drive to becoming fully autonomous, making their own life or death decisions, doesn't that disciplined, traceable, and rigorously tested blueprint like the V model become not just important, but maybe more critical than ever before? Something to think about. Thanks so much for joining me.